Always Encrypted in SQL Server 2016 is about protecting sensitive data. This sensitive data is designed like credit card numbers, national identification numbers, or even something like social security numbers. Now, the person who owns the data can decrypt the values, while non-owners, like DBAs, can manage the system but not see the encrypted data. Always Encrypted is featured because it's protecting the sensitive data like we mentioned of credit card numbers or ID numbers. You can even use this in Azure SQL databases in the cloud or on-premise in 2016. It allows clients to encrypt sensitive data inside the client applications, and it never reveals the encryption key to the engine itself. As a result, the feature provides the separation needed between those who actually own the data, the ones that really want to view it, and those who manage the data but should have no access. It also is not on the entire database, but on a column level, which we'll see later, which makes it easier to just encrypt the sensitive data. By ensuring the on-premise DBAs, cloud administration, or any other highly privileged individual can only authorize users but cannot access the encrypted data. This is a great separation of the use of an application versus managing the system. Always Encrypted enables customers to confidently store sensitive data outside of their direct control. This allows organizations to encrypt this data at rest and in use for storage in Azure, which makes the cloud implementation more and more available to people because now they know their data can be encrypted. You can enable delegation of the on-premise DBAs to third-party applications, or you can even reduce security clearance requirements for your own DBA staff. With Always Encrypted in SQL Server 2016, the actual encryption is at the table level, not the database file level. So, data is sent and received encrypted. This means you have to have a key in the application to decrypt the data. There is a master key as well as a column key, and you'll see this in a demonstration. The key is stored in a Windows container installed on the client machine and/or server. There is system management, but no user or client interaction. The really nice part of this feature, which is new to SQL Server 2016, is data is encrypted when exported and transported across a network. So, this feature makes encryption transparent to application. The enabled driver is installed on a client machine. This achieves the automatic encrypting and decrypting of sensitive data in a client application. The driver encrypts the data in sensitive columns defined inside the database before passing the data to the engine. It'll automatically rewrite queries so that the semantics in the application are preserved. Similarly, the driver is transparent when it decrypts data or stored encrypted database columns and contained in query results. So of course the question now is, how does Always Encrypted work? Well, you can configure this feature for individual database columns containing the sensitive data. So if there's only 5 to 10 columns in your whole database that needs to be encrypted, you don't have to encrypt the entire database. When setting up the encryption for a column, you specify the information about the encryption algorithm and cryptographic keys used to protect the data in the table columns. Always Encrypted uses two types of keys: column and master encryption keys. A column encryption key is used to encrypt data in an encrypted column. A column master key is a key protecting the key that encrypts one or more column encryption keys. So, once you create a master key in a database, you can basically use that for all columns. The individual columns will need their own encryption keys, and these can be generated by the wizard. The database engine stores the encrypted configuration for each column in what's called metadata. However, the engine never stores or uses the keys of either type in plain text, always encrypted, always using security. It stores only encrypted values of column encryption keys. The information about the location of the master key is also stored in the metadata. This is internal trusted key stores, and those key stores can be your Windows certificate store, Azure Key Vault, or even some sort of hardware security model. With Always Encrypted in SQL Server 2016, the column will need to be determined if you use randomized or deterministic type column encryption. The database engine never operates on plain text data stored in the encrypted column, but it still supports some queries on encrypted data, depending on the encryption type for the column. Always Encrypted supports these two types, randomized and deterministic. The deterministic always generates the same encrypted value for any given plain text values. You use this because you need to allow point lookups like where clause, equality joins like from inner joins, and grouping and indexing on these encrypted columns. You may, however, allow unauthorized users to take a guess of the information. So some people might try to decrypt it based on a pattern. They can examine these patterns in the encrypted column, especially if there's a small set such as yes, no, upper versus lower regions, and things that have very few possible combinations. The deterministic encryption uses a column correlation of binary to sort order, so that has to be on the column in order to use this sort of deterministic encryption. On the other hand, randomizes uses a method that encrypts data in a less predictable manner. But even though it is more secure, searching, grouping, indexing, and joining is not easy to be done with a randomized encryption. So you have to pick these two depending on if you're having lots of joins and where clauses or if you need to index it. We'll look at two examples of this. So the deterministic encryption for columns will be used for searching and grouping parameters. For example, like a government ID, which is unique to all people. But randomized encryption is for data that is confidential and you don't want to be able to look at these patterns, nor are they used in groupings with other records or used in other join tables. And even if you're doing that, you might want to separate part of the data in a randomized encryption column to another column in order to do specific types of groupings. This is a demonstration of using Always Encrypted. First, we're going to launch SQL Server Management Studio 2016. We're going to initiate a wizard that's going to help us step through creating the encryption keys as well as encrypting the data. I'm going to drill down into databases and go to my small DW. I'm going to go to Task and hit Encrypt Columns. Now what it's going to do is going to prompt me for a particular wizard. I'm going to cancel that and go to another database. I'm going to task Encrypt Columns again, and I'm going to select Next in the Welcome screen. Now in the database itself, I can drill into the particular tables and columns that I want to have encrypted. And you'll see in this database, there's already a deterministic pick for our customer alternate key, and a encryption key, which is our master, has been selected. We also have birth date, marital status, and gender. You'll see those are randomized, whereas the other one is deterministic. So let's go back to the DW, Task, and Encryption. Click Next and look at something at a database that hasn't been encrypted yet. So we'll select Customer Alternate Key and choose Deterministic. Since we're joining this with other tables and the data in here is pretty unique, Deterministic is okay. But for something like birth date, which is not searched on nor joined on, we'll pick randomization. And since there's possibilities that the birth date occurs more frequently, just like marital status and gender. So those are randomized so that it's not easily to be able to determine what's inside of the encrypted part of the column. The deterministic, remember, is something that's more likely to repeat based on the same exact value. But since customer alternate key is not a similar values, most of them are very unique, deterministic is the way to go. When we click next in the wizard, it'll ask us about the master key configuration. We'll auto-generate that column master key, and then it tells us where to store it. It's a good idea here to, if you're doing encryption, to use your service account. Most secure SQL Server systems will have an Active Directory service account to run the database engine. If you log in on that, then your master key can be common to all databases that you encrypt. If you notice, the task wizard lets us step through one database at a time, though we are able to encrypt multiple columns and multiple tables. The select of the key store is our Windows certificate store, which is pretty secure on your Windows operating system. But you also have the ability to sign in to Azure and keep that information in the cloud. You can even select what Azure Key Vault to place it in. Because of the Cloud Code First initiative with Microsoft, most things are being done in the cloud before implemented on premise. And encryption, or always encryption, is one of these. This helps you move to the cloud more quickly because you know that if you can do it in the on-premise version, then you can also do it in the cloud. As we click next, we can either run or generate a PowerShell script or proceed now to finish. A lot of people like PowerShell, and scripting it for later run when maybe a maintenance window is available might be the better option. In the upper left, we can always go back and step through one of these steps. But if we're finished, we can click the finish button and proceed. I'm not going to do that. What I'm going to do is go into a database that has already been decrypted the same way. And I'm going to select the DIM customer table. And what you'll notice in here is that those particular columns have been encrypted. The customer alternate key as well as the birth date. Now, in order to see that data on this particular machine or in an application, what you can do is connect with a certain property. So since my Windows certificate store holds this encryption key, I can just paste a property in my connection string for SQL Server Management Studio. It's called column encryption setting equals enable. And if I connect to this, I get a new connection. And if I go query that same table by changing that connection, so connection, change, make sure I have that in my options, and connect. Those two encrypted columns is now going to use that master key to decrypt. And now my alternate customer key and my birth date is presented to me at an application level. So in order to use this, you have to have that certificate store on a client machine. You can export the encryption key and import it into a different machine, and that could all be used with that PowerShell script. Also, you'll notice that at one point it looks encrypted, and then at another point it looks decrypted.